Welcome and good afternoon, everyone. My name is Kishore Gangwani. I work as architect at CVS Health, and I focus on application security. Today, I will be sharing with you some ways to improve security if you are implementing long-lived sessions. Long-lived sessions are, it's a way to enable users that they log in one time, and then they can use the application for many days or even many weeks. And this is sometimes called keep me signed in feature. And before we do that, I will shortly talk about why should we care about providing a good login experience to the users and how the long-lived sessions can help us. As you might have noticed, or maybe your customers complain that logging in with passwords is not easy for some people. They have so many passwords and they forget. And if they can log in, if they can remember the password, they cannot complete the second factor authentication. And this leads to a lot of frustration. And if they cannot log in, they will sometimes call your customer support. And as we heard yesterday, that customer support calls are very expensive. And some data says that one call can cost up to $70. That's a lot of money. And also, frustration can lead to lower satisfaction, and which can affect customer loyalty, and in the long run, maybe it will affect your bottom line. And more immediately, the customers may not complete the transaction. If they get very frustrated, they may have added items to their shopping cart, but they will not purchase it because they just cannot log in. So it really matters to provide a good login experience to the users. And one way to do it is to simplify your login experience. And these are a few ways you can do that. First is to use social logins. And if you use social login, customers don't have to remember your app-specific password. They can use another account to do a single sign-on to your application. And the second is FIDO. This is really a preferred solution nowadays, and we should use it as much as we can. In FIDO-based solutions, users can authenticate by using biometrics or some other way, and this provides a very seamless experience. It's highly secure, and it's getting adopted more and more. Third option is push notification. It's not used as much as the other two, but still it allows users to log in without password by using, if they are logged in device one, they can log into another device without using the password. So these are really good. Our first approach should be to implement these, make the experience better, simplify the way users can log in. But it's not always easy. For example, you might be working in a regulated industry, and in that industry, some of the approaches we saw earlier may not be in the approved list. For example, if it's a highly regulated industry, you cannot use social login. Users cannot use social login to log in. And also, it's significant work. Most applications already have username and password implemented, and to support FIDO, it is not easy. And the problem could be from the customer side also. For example, they may not have a device which supports FIDO, or they are used to logging in with their password, and they don't want to change the habit. And some people have privacy concerns, which are not founded on real reasons, but they are hesitant in using biometrics like fingerprint for logging in. So to complement simplifying the flow, we can use long-lived sessions. So in the long-lived session, users don't have to log in every time they use the application. Once they log in, for many days, they can continue application on the same device. And a common way to do it, if you're using OAuth IDC, is to use combination of access and refresh tokens. Access tokens are short-lived. Maybe they last for a few minutes. And they are used for making API calls. And after the access tokens expire, you can use refresh token to create new access tokens, and which live for a longer time, maybe a few days. And they enable long-lived sessions. And if you don't ask users to log in frequently, they may not be as much frustrated even if your login process has high friction. The problem with long-lived refresh tokens is they provide a longer window for the attacker if you have any security issues. So they have more time to steal the token, and they can use it. So we have to take some extra steps to attain the adequate amount of security if we have long-lived sessions or long-lived tokens. So first thing you should absolutely do is implement the standard security measures, and that includes how do you secure the tokens in the client, or if you have addressed all the OWASP 10 issues. That's like the basic hygiene. That doesn't matter how long your tokens are, how long your sessions are. This is a must. We have to do it. And there are some additional things you can do which are specific to securing the tokens. First one is using the rotating refresh token. So this is a recommendation from OAuth 2 anyway, if you are storing the tokens in a public client, that your token should be usable for creating only one access token. After that, it becomes invalid. And if you create an access token, you get another refresh token, and you can do the refresh cycle again. So it provides two advantages. One is that because the token is short-lived, the attacker has a smaller window to use and to steal it and use it. Second thing is that in some cases, you can actually detect if someone steals your token. So this is one such example. Let's say an attacker stole your token, RT1, it's a refresh token, and used it to create a pair of tokens. Because it's a rotating token, authorization server will immediately invalidate it. And when the authentic client, the real client, calls the refresh token, server sees that this token is invalid, it was already used, so something is wrong. And even if server doesn't know if this client is the attacker or the previous client was the attacker, it can just invalidate refresh token 1, refresh token 2, and attacker cannot continue stealing the resources or calling your APIs. So this is one way. Other way is that when you create a token, you can bind the token to the client in a certain way. So one way to do it is using the client fingerprinting. When the client does a request for the token, the server can look at the properties of the client. For example, what's the operating system, what is the geolocation, or if you want to do in a sophisticated way, calculate the canvas fingerprint, and bind that and use that to create a kind of a fingerprint and link the fingerprint to the token. So when the request comes, you look at the token, recalculate the fingerprint, and check with the original fingerprint. And if the fingerprint matches, it gives us confidence that it's the same client which created the token and let the request through. But if the fingerprint is changed, let's say the token was created from a request coming from North America, but this API call is from South America, user cannot travel a long distance in short time, so reject the request. Or if the operating system changes from Android to iOS, something is wrong. Another way to bind the token to the client is using depop, and depop is again an OAuth spec. So in this approach, when the user makes a token call, it creates a private key and a public key. And with the token request, it sends two things. One, it sends the depop proof. It's a format is defined in the spec. And it includes the public key, and it also creates a signature which proves to the server that the client actually has the private key, and it can validate with the public key. So authorization server will link the public key with the token, and like in the previous case, when the request comes, the client has to recalculate the depop proof with the private key, and the server will check the signature, check the public key is the same, and it again gives server the confidence that the client is the same which created the token earlier. Other thing you can do is to soft expire the tokens. Even if you implement long-lived session, it doesn't mean that you have to support all the functionality for the long-lived tokens. If there are some high value or high risk features, you can ask for a user to log in again. And for rest of the features, you can support the long-lived token. So in this example, so if the user has logged in 5 days ago, they should be allowed to order something and ship it to an existing address because we have confidence that the address actually belongs to the user. They have used it before. But if the user is shipping to a new address, that's a red flag, and we should ask user to authenticate again. And similarly, if the user is updating profile information, it's a high-risk transaction, and we should ask for authentication again. So the supporting long-lived session doesn't have to be all or nothing. We can find a middle ground, depending on how much risk we want to take. The approaches we have discussed so far don't involve the user. But we should not hesitate in asking user to share the work for improving the security. Means they have equal stake in making sure the resources are not compromised, they are not stolen. So we should not hesitate in asking users support in that. And what we can do is so there are many ways. So there are a few listed here. One way is that whenever a user logs in, we can prompt the user on an existing session that a new login has happened, or we can send an email. And if user does not recognize the login, they can always do a logout or change the password to take some corrective action. And if we are supporting long-lived sessions, it's very possible that users forgot to log out and the sessions are active and they are not even aware of it. So we should provide an easy way for them to check what are the active sessions they already have. And if we also provide a feature to do some kind of a global logout, they should be able to say that log me out of all my active sessions, because there are some sessions which I don't recognize. And this is an added layer of security. But I just want to caution you that even if you implement all the mitigations, all the risks don't go away. If your token is living for a long time, there will be a higher risk that it will be stolen and misused. And you can reduce the risk, but you cannot take the risk away completely. So you have to decide based on how much user experience you want to improve, how much is the risk appetite, and you have to draw the line, how much long the token should live, or what features should be supported, what shouldn't be supported. And in the end, this is the summary of steps we talked about to secure the tokens. And I think we have a few minutes for questions and answers, if you have any. And thank you for your time. I hope some of the information was useful to you, and it may help you improve security in your future work. If there are no questions, thank you for coming, and have a nice evening.